Let us begin by quieting the mind. Take a moment to settle into where you are right now. Let the noises of the day fade into the background, becoming nothing more than a distant hum. Breathe in slowly, filling your lungs with the air of this present moment, and breathe out, releasing the tension of the hours that have passed. We are going on a journey. It is a journey that does not require movement, but rather a shifting of perspective. We are going to cast our gaze upward, away from the solid ground beneath our feet, away from the atmosphere that cradles us, and out into the velvet silence of the cosmos. For as long as humanity has possessed the ability to wonder, we have looked at the night sky with a mixture of awe and longing. The stars have always been there, static and serene, tracing their slow arcs across the heavens. To our ancestors, they were campfires of the gods, or pinpricks in a dark curtain revealing a greater light beyond. They were beautiful, but they were distant. They were mysteries written in a language we could not yet read. But we have always wanted to see more. We have always wanted to see clearer. We are a species defined by our curiosity, by our need to understand the scale of the stage upon which we stand. And so, we built a machine. A monumental testament to human ingenuity and patience. We named it the James Webb Space Telescope. But let us think of it not as a collection of metal and mirrors, but as an eye, a golden eye designed to see the unseen, designed to peer through the dusty curtains of the cosmos and look back to the very beginning of time. Imagine this golden eye now. It is not here on Earth. It is floating in the profound stillness of space, 1 million miles away from our planet. It sits at a stable point in the void known as Lagrange point 2. It is a place of balance, where the gravity of the Sun and the Earth combine to hold a satellite in a steady embrace. Here, it is cold, colder than any winter we have ever known. The telescope is shielded from the heat of the Sun by a kite-shaped layers of material, thin as human hair, stretching out like a silver tennis court. On the dark side of this shield, the temperature plunges to nearly absolute zero. In this frozen silence, the telescope waits. It listens. It watches. Its mirror is a honeycomb of 18 hexagonal segments, plated in pure gold. Gold is not chosen for its vanity, but for its physics. Gold is the perfect reflector of infrared light, and infrared is the language of the deep universe. You see, the universe is expanding. As space stretches, it pulls light with it. The visible light from the first stars and the oldest galaxies has been traveling for billions of years. Over that unimaginable distance, the light has been stretched, pulled like a rubber band, shifting from the visible spectrum into the infrared. To see the beginning, we must look with heat, not just with light. We must look with the golden eye. When the James Webb Telescope first opened its eye, the world held its breath. We did not know exactly what we would see. We knew the math, we knew the engineering, but the reality of the cosmos often defies our simulations. Then, the first image arrived. It was a picture of a cluster of galaxies known as Seme CS0723. But the name matters less than the feeling. To understand the scale of what was revealed, we must use an analogy. Imagine you are standing on a beach at night. You reach down and pick up a single grain of sand, just one tiny, rough grain of silica. Now, hold that grain of sand at arm's length, holding it up against the dark sky. That tiny speck, covering a patch of sky no larger than the eye of a needle, is where the telescope looked. In that tiny speck of darkness, hidden behind a single grain of sand, the telescope revealed thousands of galaxies. Thousands. Let that sink in. In a patch of sky that looks empty to the naked eye, there are thousands of islands of light. Each one of those galaxies contains hundreds of billions of stars. And around those stars likely circle countless worlds. The image is a kaleidoscope of light. There are bright, white glows of foreground galaxies, massive clusters of matter that bend the fabric of space itself. And then, peering through the gaps, are the arcs of red and orange. These are the ancient ones. These are galaxies from the dawn of time, their light bent and magnified by the gravity of the clusters in front of them. a phenomenon called gravitational lensing. The universe itself acts as a magnifying glass, allowing us to see what should be impossible. It is beautiful, but it is also overwhelming. This is the first hint of the terrifying scale we are here to explore. Not terrifying in a way that suggests danger, but terrifying in the old sense of the word. Awesome. Tremendous. A scale that strips away our ego and leaves us standing in naked humility before the vastness. As we stare into that first deep field, we realize that the blackness of space is an illusion. The dark is not empty. It is merely full of light that has been too faint, too old, and too far away for us to see. Until now. The golden eye has blinked open, and suddenly, the room is full of ghosts. Ghosts of the past. Ghosts of stars that burned out long before the Earth was even born. We are looking at a history book written in photons, and we have only just opened the cover. Rest here for a moment in this realization. The grain of sand. The thousands of galaxies, the infinity that lies in every direction. If you were to take that grain of sand and move it to any other part of the night sky, you would see the same thing. More galaxies, more light, more history. There is no end to it. The universe is a crowded place, teeming with energy and matter, stretching out into a darkness that goes on forever. And we are seeing it for the first time in high definition. We are seeing the texture of the cosmos. As we drift deeper into this meditation on scale, we must address the concept of time. In our daily lives, time is measured in seconds, minutes, hours, and years. A century is a long time. A millennium is ancient history, but in the view of the James Webb Telescope, time behaves differently. Distance is time. They are the same currency. When you look at the moon, you are seeing it as it was 1.3 seconds ago. When you look at the sun, you are seeing it as it was 8 minutes ago. If the sun were to suddenly vanish, we would not know for 8 minutes. We are always living in the past of the objects we observe. Now, extend that logic to the deep field. The light from those faint red smudges in the background of the Webb images has been traveling for over 13 billion years. Let us try to visualize 13 billion years. It is a number so large it becomes abstract. Imagine the entire history of the Earth, 4.5 billion years compressed into a single day. The formation of the planet happens at midnight. Life begins in the early hours of the morning. Dinosaurs appear late in the evening, around 11 p.m. Humans, you and I, appear in the final fraction of the very last second before midnight. The light Webb is catching comes from 3 days ago in this analogy. It comes from a time before the Earth existed, before the Sun existed, before the Milky Way galaxy had fully formed. We are looking at the universe's childhood. This is the terrifying scale of time. We are temporary visitors in a house that has stood for eons. The structures we see in these images, the swirling spirals, the colliding clouds of gas, are the architects of our own existence. The carbon in our cells, the oxygen in our lungs, the iron in our blood, all of it was forged in the hearts of stars that lived and died in these ancient epochs. We are connected to this vastness. We are not separate from it. We are made of it. Let us focus on one specific feature revealed by the telescope, the Carina Nebula. In the images sent back to Earth, we see what looks like a mountain range made of rust-colored clouds set against a blue, sparkling sky. It looks like a landscape. It looks like somewhere you could hike. You can see peaks and valleys, ridges and plateaus. But these are not mountains of rock. They are mountains of gas and dust. They are the cosmic cliffs. The scale of these cliffs is difficult to comprehend. The mountains you see in the image are 7 light-years high, 7 light-years. 1 light-year is nearly 6 trillion miles. So, these cliffs of dust are roughly 42 trillion miles high. If you were to fly a commercial airplane along the face of these cliffs, it would take you millions of years to reach the top. And yet, in the grand scope of the galaxy, this nebula is just a tiny speck, a small nursery where stars are being born. The telescope allows us to peer through the dust. In previous images, the clouds were opaque. We could only see the surface. But Webb sees in infrared. Infrared light can penetrate the dust. It reveals what is hidden inside. And what is inside? Stars. Glittering newborn stars. We see them nestled in the gas, glowing with a fierce young light. We see jets of energy bursting from them, carving out caverns in the nebula. We are witnessing the process of creation itself. This is how our sun was born. This is how our solar system began. It is a violent, energetic, and beautiful process, frozen in a silent image. The scale here is not just about size, but about complexity. Every single point of light in that nebula is a sun. Every sun has a story, a life cycle, a destiny. Some will burn bright and die young, exploding as supernovae, scattering their heavy elements into the void to become seeds for future planets. Others will burn slowly and steadily for billions of years, perhaps nurturing life on rocky worlds that circle them. There is a calmness in accepting this scale. When we confront the sheer magnitude of the cosmic cliffs, our own problems, our own worries shrink to their proper proportion. The anxieties that plague us on a Tuesday afternoon seem to evaporate when placed next to a wall of gas 42 trillion miles high. The universe does not hurry. It creates on a timescale that renders our lives as mere blinks. And yet, we are the universe observing itself. We are the way the cosmos knows it exists. The James Webb Telescope has also turned its gaze toward the Stephan's Quintet, a grouping of 5 galaxies locked in a gravitational dance. Here, we see the slow-motion collision of worlds. 4 of the galaxies are interacting, pulling at each other, stretching out long tails of stars and gas. It is a cosmic ballet that unfolds over hundreds of millions of years. In the images, we see the shockwaves. We see a ridge of turbulence where one galaxy is crashing through the cluster at millions of miles per hour. The shockwave ignites the gas, causing it to glow. It triggers the formation of new stars. Destruction and creation inextricably linked. The scale of this collision is monumental. The distance between these galaxies is vast, yet they are bound together. They are merging. Eventually, billions of years from now, they may form a single, massive elliptical galaxy. Webb shows us the detail of this violence. It shows us the bright, active core of the topmost galaxy, where a supermassive black hole is feeding. The light from that black hole outshines the billions of stars surrounding it. We are looking at forces that defy imagination. The gravity of a black hole, the momentum of a colliding galaxy, the energy of a billion suns. And yet, looking at the image on a screen, it is silent, it is peaceful, it is a painting of light. This is the paradox of astronomy. The most violent events in the universe appear to us as serene, static works of art. The distance protects us. The scale insulates us. We can watch the dance of giants from the safety of our small blue world. The terrifying nature of this scale lies in the realization of how much is happening out there all the time, without our knowledge or permission. Whether we look or not, the galaxies collide. The stars are born. The black holes feed. The universe continues its grand, complex evolution in the dark. We used to think the space between galaxies was empty, a true void. But the longer we look with the golden eye, the more we realize that empty is a relative term. Even in the darkest patches, there is structure. There are filaments of dark matter, invisible webs that hold the visible universe together. The galaxies we see are like dewdrops clinging to a spiderweb. The web itself is vast, unseen, and mysterious. Webb is starting to show us the light of the very first galaxies that formed on this web. These are the red dots that astronomers are buzzing about. They look like simple smudges, but they are surprisingly bright. They are surprisingly big. This is a mystery. According to our old models, galaxies in the early universe should have been small, messy, and dim. They should have been infants. But Webb is finding teenagers in the nursery. It is finding galaxies that are too massive, too organized, and too bright for their age. The universe grew up faster than we thought. This challenge to our understanding is gentle, but profound. It reminds us that we do not know everything. The scale of our ignorance is perhaps the only thing that matches the scale of the universe. But this ignorance is not a failure. It is an invitation. It is an invitation to keep looking, to keep wondering, to keep refining our golden eye and peering deeper into the abyss. As we end this second part of our journey, let the image of the cosmic cliffs and the dancing galaxies settle in your mind. Hold the grain of sand at arm's length once more. In that grain of sand lies the history of creation. In that grain of sand lies the future of discovery. The universe is vast, yes. It is incomprehensibly large, but it is also accessible. It has sent its light across the eons, waiting for us to build a bucket large enough to catch the rain of photons. We have built that bucket. We are catching the rain. And the storm is just beginning. We have looked at the grand tapestry. We have seen the galaxies scattered like diamonds on black velvet, stretching back to the dawn of time. Now, let us shift our focus. Let us pull our gaze inward from the edge of the universe to our own galactic neighborhood. We are going hunting for worlds. For centuries, we believed that our solar system was unique. We knew of only 8 planets, or 9 depending on when you were born. We knew of the gas giants, Jupiter and Saturn, draped in their storms and rings. We knew of the rocky sentinels, Mercury, Venus, Mars, and our own blue home. We assumed there were others out there circling other suns, but we could not see them. They were lost in the glare of their parent stars, like fireflies buzzing next to a searchlight. But the James Webb Space Telescope has a way of blocking out the glare. It has a way of seeing the firefly. Let us travel now to a star known as WASP 96. It is a sun not unlike our own, yellow and bright, sitting roughly 1,150 light-years away in the southern sky constellation of Phoenix. Orbiting this star is a planet, WASP 96b. It is not a world where you could walk. It is a giant, puffed-up ball of gas, larger than Jupiter but with half the mass. It hugs its star tightly, completing an orbit every 3.5 days. It is hot, sizzling at over 1,000 degrees Fahrenheit. It is a world of eternal summer, but a summer that would boil lead. Webb did not take a photograph of this planet, not in the way we take a portrait. Instead, it did something far more profound. It tasted the planet's atmosphere. As the planet passed in front of its star, the light from the star had to travel through the rim of the planet's atmosphere to reach us. As that light passed through the gas, specific colors were filtered out. The molecules in the atmosphere absorbed the light, leaving behind a fingerprint, a spectral barcode. This is the magic of spectroscopy. It is the ability to touch what we cannot reach. Webb captured this light. It spread it out into a rainbow. And in that rainbow, it found gaps, missing colors. When scientists analyzed these gaps, they found the signature of water. Water, 1,000 light-years away. Imagine the scene on WASP 96b. It is too hot for liquid oceans. There are no waves crashing on a shore. Instead, there is steam. There are swirling, roiling clouds of water vapor. Before Webb, we thought this planet was clear skies. We thought it was haze-free. But the golden eye looked closer. It saw the subtle dimming of light that betrayed the presence of clouds and haze. It saw a weather system on a world that no human will ever visit. There is a distinct kind of awe in this. We are sitting on a small rock, looking at a graph on a computer screen, and that graph tells us that there are clouds floating in the sky of a hot Jupiter a quadrillion miles away. We are sensing the breath of a distant world. But let us go further. Let us travel to a system that captures the imagination more than any other. The TRAPPIST-1 system. Here, 40 light-years from Earth, a mere stone's throw in cosmic terms, lies a small, cool red dwarf star. And huddled around it, like campers around a dying fire, are 7 worlds. 7 Earth-sized planets. It is a solar system in miniature. If you were to stand on the surface of one of these worlds, the other planets would look large in the sky, appearing as massive, bright moons, possibly showing their phases and geographical features to the naked eye. Webb has turned its gaze here. It is searching for atmospheres. It is sniffing the air of these rocky worlds. The scale of this challenge is terrifyingly precise. It is like trying to spot a gnat crawling across a car headlight from miles away, and then trying to determine the color of the gnat's wings. We have learned that the innermost planet, TRAPPIST-1b, likely has no atmosphere. It is a bare rock, scorched by its sun, radiating heat into space. It is a dead world similar to our Mercury. But there are others. There are planets in the habitable zone, the Goldilocks region, where temperatures might be just right for liquid water. Webb is slowly, methodically, peeling back the layers of mystery. It is looking for carbon dioxide. It is looking for methane. It is looking for oxygen. Why does this matter? Why do we care about the air of a world we can never touch? Because it redefines our place in the universe. If we find an atmosphere rich in methane and oxygen, a combination that typically doesn't last long without life, constantly replenishing it, we will have the first hint that we are not alone. The silence of the universe has always been its most terrifying quality, the sheer, empty quiet. But if we find these chemical signatures, the silence breaks. It is replaced by a hum of biological processes, of life breathing, eating, and existing. Even if we find nothing, even if we find that the TRAPPIST worlds are barren, wind-swept deserts, that too tells us something. It tells us how precious our own blue marble is. It tells us that life is rare, that the conditions for breath are a cosmic lottery win. The scale of the universe is not just about distance, it is about probability. Out of billions of galaxies and billions of stars within them, what are the odds of this? Of us? Of water? Of clouds? Webb is the tool that calculates the odds. It transforms the terrifying vastness of space into a laboratory. It turns the alien into the familiar. We look at the graph of JWST 39b, another hot giant, and we see the spike for carbon dioxide. The first clear detection of CO2 on a planet outside our solar system. It is the same gas we breathe out, the same gas that warms our planet. It is there, floating in the dark, weaving a blanket around a gas giant 700 light-years away. The chemistry of the cosmos is the chemistry of home. We are finding that the ingredients are everywhere. The recipe is universal. The only question that remains is, how often does the oven turn on? We leave the planets now. We leave the cool red dwarfs and the hot Jupiters. We travel back into the deep clouds. We travel to the places where stars are made. If the galaxies are the cities of the universe, the nebulae are the nurseries. And the most famous nursery of them all is the Eagle Nebula. Within this nebula lies a structure that has become an icon of our exploration. 3 towering pillars of cold gas and dust standing tall against the glow of young stars. We call them the Pillars of Creation. Hubble showed us these pillars years ago. They were dark, shadowy monoliths, mysterious and opaque. They looked like stone statues eroding in a cosmic wind. But when James Webb looked at the Pillars of Creation, the statues became glass. In the near-infrared image captured by Webb, the pillars are no longer dark. They are translucent. They glow with a ghostly, golden light. We can see through the dust. We can see inside the pillars. And what we see is a thunderstorm of star formation. At the edges of the pillars, there are bright red orbs. These are not background stars. These are protostars. These are baby stars that have just ignited. They are only a few 100,000 years old, infants in the lifetime of the universe. As these young stars collapse under their own gravity, they spin, they heat up, and they launch supersonic jets of material out into the gas around them. Look closely at the tips of the pillars. You can see wavy lines of crimson like lava flowing down the side of a volcano. These are the bow shocks. The jets from the young stars are slamming into the surrounding gas and dust, creating ripples of energy. The scale of these pillars is dizzying. The tallest pillar is about 4 light-years long. To understand this, consider the Voyager 1 spacecraft. It is the fastest, most distant object humanity has ever built. It has been traveling for nearly 50 years. It has not yet traveled one light day. To travel the length of just one of these pillars at the speed of Voyager would take nearly 80,000 years. And yet, these pillars are temporary. They are being eroded. The massive bright blue stars at the top of the image, stars that are not in the picture but whose presence is felt, are blasting the pillars with ultraviolet radiation. They are evaporating the gas. We are watching a slow-motion destruction. The very material that creates the stars is being blown away by the stars it created. It is a cannibalistic cycle, a cosmic Ouroboros. Webb also reveals the dust in a new light. In the mid-infrared view, the dust is not a screen, it is the subject. We see the cold, skeletal structure of the pillars. We see the density. We see the reservoirs of matter that will eventually become solar systems. It is in these forges that the heavy elements are managed. The universe began with hydrogen and helium. Simple, light gases. But you cannot build a planet out of hydrogen. You cannot build a human out of helium. You need carbon. You need oxygen. You need silicon, iron, and gold. Where do these come from? They come from the hearts of stars. Inside the nuclear furnace of a sun, atoms are smashed together, fusing into heavier and heavier elements. And when the massive stars die, when they explode in glorious supernovae, they scatter these elements into the nebula. The dust in the pillars of creation is seasoned with this stardust. It is rich with the ashes of dead stars. And from this ash, new stars form, new planets clump together. And perhaps on some of those planets, living things arise, living things with carbon in their cells and iron in their blood. When we look at the pillars of creation, we are looking at our own history. We are looking at the factory where the building blocks of our bodies were assembled. The scale is terrifying because it reveals our intimacy with the violent machinery of the cosmos. We are not observers standing outside the tank. We are the fish, made of the water we swim in. Let us drift to another forge, the Wolf-Rayet star, WR24. Webb captured an image of this star that looks like a cherry blossom blooming in the night, a bright shining center surrounded by halos of purple and pink gas. This is a star on the brink of death. It is shedding its outer layers. It is coughing out massive amounts of gas and dust into space. This star is 30 times the mass of our Sun. It is burning its fuel at a furious rate. The dust it creates, the pink halo is cooling as it moves away. This dust is the seed for future worlds. Before Webb, we did not know if this dust could survive the violence of the supernova that is coming. We thought perhaps the explosion would destroy the dust, but Webb sees so much of it. Clumps of it, knots of it. It suggests that the dust survives. It suggests that even in the most violent death, the seeds of life are preserved. The terrifying aspect here is the sheer indifference of the process. The star does not know it is creating the conditions for life. The nebula does not care that it is beautiful. The physics play out with a cold mathematical precision, and yet the result is warmth. The result is us. As we drift through these clouds of gas, miles high and light years wide, we are struck by the texture of the universe. It is not smooth. It is turbulent. It is messy. It is full of cavities and ridges, filaments and bubbles. It looks organic. It looks like the inside of a cell or the neural pathways of a brain. The patterns of the micro repeat in the macro. The forces that shape a drop of water also shape a nebula. The James Webb Telescope allows us to trace these patterns. It allows us to see the connectivity of all things. From the atmosphere of a lonely planet catching the light of its star, to the towering pillars of dust birthing new suns, the story is one of flow. Energy flows. Matter cycles. Time stretches. We are standing on the shore of a cosmic ocean, and for the first time we can see the currents, we can see the depths. The water is dark and deep, but it is no longer invisible. In the next part of our journey, we will travel even further back. We will go to the edge of the map. We will look for the monsters that lurk in the center of galaxies, and we will try to glimpse the very first sunrise that ever happened. But for now, rest in the glow of the pillars. Rest in the knowledge that you are made of this same shining dust. You are a child of the nebula, looking back at your nursery. We have drifted through the nurseries where stars are born. We have tasted the air of distant worlds. Now, we must gather our courage. We are traveling to the center, to the heart of the darkness. In the middle of almost every massive galaxy, there lies a monster, a supermassive black hole. For a long time, these giants were invisible to us. We knew they were there by the way they whipped stars around like toys on a string. We knew they were there by the radio waves screaming out from their vicinity, but we could not see them clearly. They were shrouded in thick walls of dust and gas. But remember, the golden eye sees through the dust. James Webb has turned its gaze toward the centers of active galaxies. It has looked at the hearts of these beasts. And what it found is not just darkness, but light, blinding, fierce light. As matter falls into a black hole, it does not go quietly. It swirls, it heats up, it moves at a significant fraction of the speed of light. Before it crosses the event horizon, the point of no return, it glows with the energy of 1 billion suns. This is the active galactic nucleus. Webb has shown us the wind coming from these monsters. It has revealed that black holes are not just eating, they are breathing. They are blowing vast storms of gas out into their host galaxies. This is a crucial piece of the puzzle. These winds determine how many stars can form. If the black hole blows too hard, it strips the galaxy of gas. It stops the birth of stars. It kills the galaxy. The scale of this power is terrifying. A single object, smaller than our solar system, controlling the fate of a galaxy that is 100,000 light-years wide. It is a reminder that in the universe, the heavy lifting is often done by the smallest, densest things. But let us go back even further. Past the black holes, past the colliding galaxies. Let us go to the very edge of time itself. We are going to the cosmic dawn. Before there were stars, there was the Dark Ages. The universe was a fog of hydrogen gas. It was dark. It was silent. There was no light to see, and no eyes to see it. Then, something happened. Gravity began to pull the gas together. Dense pockets formed, the pressure built, and then, in a moment of cosmic ignition, the first stars turned on. This is the holy grail of cosmology, the moment of first light. James Webb was built for this specific purpose, to find the first luminous objects that burned away the fog, to see the epoch of reionization when the universe went from opaque to transparent, and it is finding them. It is finding galaxies like JWST Z1490, a name that sounds like a license plate but represents a miracle. This galaxy existed only 290 million years after the Big Bang. In human terms, if the universe is a middle-aged person, this galaxy is a picture of them as a newborn baby, just days old. The light from this galaxy has traveled for 13.5 billion years to reach us. It has been stretched by the expansion of the universe until it is deep, deep red. Only the infrared eye of Webb could catch it. These early galaxies are surprising us. They are brighter than they should be. They are richer in elements than they should be. They suggest that the universe woke up quickly, that the lights turned on with a flourish, not a flicker. It is humbling to look at these red smudges. We are looking at our ancestors, not our biological ancestors, but our cosmic ones. The first stars in these galaxies forged the very first heavy atoms. They started the chain reaction of creation that eventually led to the Milky Way, to the Sun, to the Earth, and to you. We are staring at the first sunrise. A sunrise that happened billions of years before the Earth existed, yet its light is only just now washing over us. We have reached the end of our journey, but in a universe this circular, there are no true endings. We started with a grain of sand held at arm's length. We end with a realization that we are the grain of sand. The James Webb Space Telescope has revealed the terrifying scale of the universe. It has shown us walls of gas 40 trillion miles high. It has shown us distinct worlds where rain might fall as molten glass. It has shown us the violence of black holes and the serenity of the cosmic dawn. Terrifying is the word we used, but as we sit with these images, the fear dissolves. It is replaced by something else, a feeling of belonging. The vastness is not designed to make us feel small. It is simply the nature of the room we live in. We are small, yes, but we are significant. Why? Because we can see it. We are the universe's way of knowing itself. Without eyes to see the cosmic cliffs, are they beautiful? Without a mind to comprehend the age of the ancient light, does the time matter? We have taken metal from the earth and gold from the hills, and we have fashioned an eye. We have thrown that eye into the frozen void 1,000,000 miles from home. And through that eye, we have connected with the infinite. The scale of the universe tells us that our daily struggles are small, but it also tells us that our potential is vast. We are capable of understanding things that happened 13 billion years ago. We are capable of mapping the invisible winds of black holes. There is a peace in this perspective. When the noise of the world gets too loud, when the rush of modern life feels overwhelming, we can close our eyes and remember the deep field. We can remember that right now, as you breathe, the galaxies are dancing, the stars are being born in the pillars of creation. The atmosphere of a distant world is swirling with clouds. It is all happening. It is all continuing. The great silent machinery of the cosmos grinds on, majestic and slow. The James Webb Space Telescope will continue its watch. It has enough fuel to last for 20 years or more. It will find things we haven't even imagined yet. It will rewrite the textbooks. It will give us new dreams. But for now, let us be content with what we have seen. Let us be content to be the observers. The witnesses. The conscious sparks in the dark. Take a final deep breath. Feel the gravity that holds you to this planet. It is the same gravity that holds the galaxies together. Feel the warmth in your body. It is the energy released by the burning of carbon, the same carbon forged in the hearts of dying stars. You are not just in the universe, you are of the universe. The horizon is endless, the scale is infinite, but you are here, and you are looking up. And somewhere in the deep, cold silence of Lagrange Point 2, the golden eye is wide open, watching, waiting for the next revelation. Good night to the stars, good night to the galaxies, and good night to you. Let us linger a little longer in the dark. Usually, when we tell the story of the universe, we present it as a finished book. We speak of the Big Bang, the expansion, the stars and the galaxies as if they are settled facts, arranged neatly on a shelf. But the golden eye of the James Webb Telescope has done something more than just show us pretty pictures. It has begun to show us the cracks in our understanding. There is a quiet tension in the world of astronomy, a whisper that is growing louder. It is called the Hubble tension. To understand it, we must imagine the universe as a balloon being inflated. We know it is getting bigger. We know it is stretching. But we need to know how fast. If we look at the early universe, the baby picture captured by other telescopes looking at the leftover heat of the Big Bang, we can calculate how fast the universe should be expanding today. The math is precise. The prediction is solid. But if we look at the nearby universe, the galaxies close to us, and measure how fast they are moving away, we get a different number. The universe is expanding faster than it should be. For years, scientists thought this was just an error, a mistake in the measurements. Maybe our rulers were broken. Maybe our eyes were playing tricks on us. They hoped that the James Webb Telescope, with its perfect infrared vision, would resolve the dispute. They hoped it would prove that the two numbers were actually the same, but Webb did not do that. Webb looked at the stars used to measure these distances, special blinking stars called Cepheids, and it measured them with unprecedented accuracy. It cleared away the dust, it separated the starlight from the background noise, and it confirmed the discrepancy. The tension is real. The universe is not behaving as our models predict. This is not a failure. In science, this is the most exciting moment possible. It means there is something missing in our story. Perhaps there is a force we haven't discovered yet, an exotic form of early dark energy that gave the universe a kick in its infancy. Perhaps our understanding of gravity, passed down from Einstein, needs a small adjustment on the grandest scales. Webb is calmly, quietly handing us the evidence that says, you do not know everything yet. It is a humbling reminder of the scale of the mystery. We are like ants trying to understand the geometry of a highway by watching the wheels of passing cars. We have learned so much, but the road is long and the map is still being drawn. Let us drift now to another mystery. Webb is unraveling the mystery of the missing matter. When we weigh the universe, calculating the mass of all the stars, all the gas, all the dust, we come up short, desperately short. The visible stuff, the stuff you and I are made of, makes up only about 5% of the universe. 5%. The rest is dark matter and dark energy. Invisible, untouchable. Webb cannot see dark matter directly, it is a ghost. But it can see the shadow the ghost casts. Remember the gravitational lensing. The way the galaxy clusters warp the light of the background stars. That warping is caused by mass. By measuring the warp, we can map the mass. Webb is creating the most detailed maps of dark matter ever made. It is showing us the invisible scaffolding that holds the galaxies together. It is revealing that the bright, shining structures we see are just the foam on top of a deep, dark ocean. There is a serenity in accepting this. We are the minority. The luminous world, the world of light and atoms, is a rare jewel set in a vast sea of darkness. And yet, that darkness is not empty. It is full of potential. It is full of structure. Webb is also turning its eye to the empty spaces between stars. The interstellar medium. We used to think of the space between stars as a vacuum, a true nothing. But Webb sees it differently. It sees the polycyclic aromatic hydrocarbons, complex carbon molecules floating in the void. Think of it as smoke from the celestial fires. These molecules are the building blocks of life. And they are everywhere, drifting in the silence between the suns. It suggests that the universe is not just compatible with life, but that it is preceded with the potential for it. The ingredients are waiting in the pantry, drifting in the cold, waiting for a gravity well to pull them in and cook them into a world. As we approach the final movements of this extended journey, we must turn our thoughts to the future. Not just the future of the universe, but the future of the golden eye itself. The James Webb Space Telescope is a finite machine. It carries a limited supply of fuel to keep it in its stable orbit. It has a lifespan, 5 years, 10 years, maybe 20 if we are careful. One day, the fuel will run out, the thrusters will stop firing, the telescope will drift away from its balanced point in Lagrange 2. It will begin a slow, lonely wander around the sun. Its instruments will warm up. The infrared vision will fade as the heat of the cosmos seeps in. The golden eye will go blind. But the light it captured will remain. We are building an archive. Every image, every spectrum, every graph downloaded from the telescope is stored in a digital library. This data is not just for the scientists of today, it is for the scientists of tomorrow. Imagine a child born today. 50 years from now, they might be an astronomer. They might have a new theory, a new question that we haven't even thought to ask. They will be able to go into the archive and look at the data Webb collected in 2024. They will see something we missed. The telescope is a time capsule. It is a gift we are sending to the future. And what of the universe's future? Webb helps us peer into the deep future by showing us the deep past. By understanding how the expansion is accelerating, we can guess how the story ends. It seems the universe will continue to expand. The galaxies will move further and further apart. The night sky will slowly, over billions of years, become darker. Eventually, the other galaxies will be so far away that their light will never reach us. If there are civilizations in the distant future, they might look up and see only their own galaxy. They might think they are alone in an island universe. They will not see the cosmic web. They will not see the Big Bang's afterglow. We are living in a privileged time. We are living in the golden age of cosmology. We are alive at the exact moment when the universe is observable. We can see the beginning, we can see the neighbors, we can see the structure. This realization brings a profound sense of gratitude. We are lucky to be here. We are lucky to have the glass and the gold to see the view while it is still spectacular. In the end, the scale of the universe is a mirror. When we look into the Webb images, we see the mechanics of star birth, yes. We see the atmospheric chemistry of exoplanets, yes. But we also see ourselves. We see our curiosity. We see our patience. We see our ability to work together. Thousands of engineers, scientists, and dreamers from different nations to build something that transcends borders and politics. The James Webb Space Telescope is, in a way, a cathedral. It is a structure built not for profit, not for war, but for worship. Worship of the truth, worship of the light. It floats there, a million miles away, silent and cold, a monument to human wonder. So, as you drift off, let your mind travel one last time to that point in space. Picture the sun shield, shimmering like a silver ship on a dark ocean. Picture the golden mirrors reflecting the starlight of eons. Picture the data streaming silently through the void, a river of ones and zeros carrying the secrets of creation back to a small blue planet. We are small. The universe is vast. But we are the ones who are watching. And as long as we keep watching, as long as we keep wondering, the horizon will never truly end. The universe is waiting. Sleep well, knowing that the golden eye is open, keeping watch over the night,